help me to connect with the audience. Can you also see the screen I shared?
Yes. Yes.
All right, very good. So thank you all very much for coming to this presentation. I know it is the last one for today, so I will try to be on time so that you all could go home for dinner. So it's I'm going to use about 40 minutes. Hopefully I could finish up. Then I will leave the 15 to 20 minutes for questions. Okay, so what I'm going to talk about is on the mathematical problem posing. So as you probably know, in the past several years, I have been engaged in this research topic. So I'm going to give a little bit of history about this line of research. But at the meantime, I'm going to share some findings of a new project involving elementary school math teachers. All right, so to begin with, I will say a few words about what is problem posing, just so that we could be on the same page. All right, so to me, the problem posing could be conceptualized in three ways. It's as a learning goal, which means that we want to develop students' problem posing skills. It's a learning goal. Second is that it's a cognitive activity. It's almost like the same thing, like a problem solving viewed as a cognitive activity. So students could engage in it. So got involved in the problem posing process. And the third is that problem posing could be viewed as an instructional approach, which means that through engaging in problem posing, students learn mathematics, learn important mathematics. So that's the view for that. And probably that's still not enough about what problem posing really about. So I'm going to use a quick example to talk about, okay? Quick example to talk about. The example is this. So in the figure below, AB parallel to CD show that the sum of the measure of the three angles is 360 degrees. Now, this is usually the textbook will include a problem like that. But this is not problem posing. This is a usual kind of a problem solving task. Students need to prove the sum of the three angle measures equal to 360 degrees. And later on, when we talk about problem solving, we want to give students more space, more room to think. So maybe we could change the problem a little bit here. So the problem could be changed into this. In the figure below, AB is parallel to CD. What is the sum of the measure of angle A, angle E, and angle C? Now, compared to the previous version, it's in this version, what is the sum? The sum wasn't told to the students. Instead, students needed to try and error, make a hypothesis to guess what the sum would look like. Then try to prove why the sum of three angle measures equal to 360. So that's the more open kind of task here. So now, if I go to the third version here is this. In the figure below, AB parallel to CD, please pose as many mathematical problems as you can with respect to the relationships in the figure. Now, this is a problem posing task, which means that they will, based on this figure, try to generate problems. Through generating problems, then reach the goal of learning related to mathematics. related to mathematics. So that's give you a little flavor for that. Let me give you another example. I don't know why there is red things here. So somebody probably draw down there. Maybe if it really impact on your reading, then I will turn off and try again. It will disappear later. Give you another problem posing task. So here is on the top is a situation here. Sally is having a party. The first time doorbell rings, 1 guest enters. Second, 3 guests enters. Third time, 5 guests enter. Fourth time, 7 guests enter. Then keep going like that. Keep going like that. And so we ask the student to do is for students' homework, Mr. Johnson wanted to make up 3 mathematical problems based on the above situation. An easy problem, a moderately difficult problem, and a difficult problem. And this problem can be solved using the information in the situation. So let's give you another example about problem posing task. Give you one more so that hopefully you will have some ideas what I mean about a problem posing, So imagine that you are teaching division with fractions. To make this meaningful for kids, sometimes that many teachers try to do is relate mathematics to other things. Sometimes they try to come up with real-world situations or story problems to show the application of some particular piece of content. What would you say would be a good story or model for 1 3/4 divided by 1/2? See, that's another problem posing task. Another problem posing task. Okay, so I'm going to go back a little bit, but those are the samples of the problem posing tasks. But then what I mean then, using problem posing to teach mathematics. So I will go to show you a little figure here. This 2 diagram is so this is the usual framework I use for dealing with research related to math education. But in this case is that, so the middle part is the students' learning. Students' learning is both cognitive and non-cognitive. So which means that not only the thinking skills increase, their knowledge, but also their, hopefully the attitude or the mathematical disposition will change as well. So this part dealing with curriculum materials, and this is dealing with how teachers planning, beliefs, and knowledge. But now we usually, in this framework, I view the classroom instruction as teachers set up the instructional tasks for students. Then through discourse, then solve those problems. But usually in our classroom instruction, we use so-called problem-solving tasks to reach the goal of learning mathematics for students. But in problem posing, now those tasks became the problem posing tasks. So instead of a problem-solving task, problem posing task would be replaced here. So in other words, engage students in problem posing tasks. Then through posing the problems, and then in classroom, solve students' own posed problems to reach the goal of learning. So that's what I mean about a problem posing. So let's give you a little bit of flavor about what I mean about a problem posing. Now, what I'm going to do next is that I will give you a little bit of history about the problem posing research. Okay? So very, very brief. And it believe in such a way that I really wasn't, I'm unable to include all of the researchers engaged in this work. So I only would be able to, the lines I learned from, okay? So first thing I want to go back to the George Polias. Now, George Polia, very early on, wrote a book called How to Solve It. How to solve it. In his work, in his very seminal kind of work, book, he divided problem-solving process into 4 phases. And the last phase is really looking back. Now, the looking back all really include the posing related problems. So we could somewhat trace back to George Polia about problem posing. However, in Polia's time, he did not focus on the posing process as the object of study. Instead, problems and how to solve them as the objective of study. So even though the problem posing idea has been embedded in the last phase, which is looking back. And in 1983, 2 professors, Professor Brown and Professor Water, they published a book called The Art of Problem Posing. So in this book, now this is a widely circulated book, is to create the situations for the college students to engage in the problem posing, activities. And one of the well-known ideas in this book is about the so-called strategy, what if not? What if not? So after solve a problem, what if something changed? Then what will be happening? So this book is draw quite a bit of attention from problem solving to the problem posing, And that's 1983. Now, 1987, Jeremy Kilpatrick published a book chapter in Alan Schoenfield's book called Problem Formulating. Where do good problems come from? So I viewed this chapter that is not a research per se. Instead, this book or this chapter to me is that almost like a set up a agenda to call for the research in problem posing. So even in that time, the Jeremy even didn't call it as problem posing. It's called problem formulating. But the idea would be the same, would be very similar. So in this chapter, Jeremy not only discussed how we should provide the opportunity for students to pose problems, but also called for the different areas of research in this area. For example, one of the important ideas he called for is that to examine how the problem posing abilities related to the problem solving ability. So he even hypothesized that, how well one can pose a problem may be an important indicator how well the person is able to solve problems. So he proposed theoretically about this hypothesis in this. Okay, so in 1989, the A. Silver has secured launched a grant, the project on mathematical problem posing. And he published a paper in 1994, even though his work started in 1989. It's about after a year of the Jeremy Kilpatrick's chapter. So A. Silver launched a project on problem posing. And based on his project, in 1997, he published this very important article for the learning of mathematics. And at that time, I joined his research group and became his graduate student. So that's why I keep continuing this problem posing research, because I got influence from him for the problem posing. So my favorite the picture I want to show you is that somehow I'm very proud to relate to all three of them. So I am the A. Silver student. A. Silver is a Jeremy Kilpatrick's student, and Jeremy is a George Polia student. So somehow there is a little trace about problem posing. It's really the great honor to learn those ideas from them. So because of that, I followed A. Silver and I got engaged in the somewhat about the problem posing research for this. And one thing I want to point out is this: in 2015, and a few of us, and we published a book on mathematical problem posing. Now, this book is based on the discussion group at the PME International and a research forum at another PME International, So in this book, scholars from 26 countries discussed the idea about how to do problem posing research. And in this book, I wrote a chapter on trying to synthesize by then about the problem posing research in mathematics. So my title is trying to looking at some answered and unanswered questions. So in this chapter, I proposed the 10 answered and unanswered questions. So, well, instead of I will read it one by one, I'm going to simply present it here to let you take a look at it. And for some of you, if you are interested in it, you could get a copy of the chapter and read it. If you don't, if you couldn't locate a chapter, you let me know, and I could send you a chapter, send you a copy of this chapter. So in this chapter, I used 10 questions, try to synthesize the research has been done on mathematical problem posing. In particularly, I discussed, certain things we already know, and in certain aspects we still don't know. We still need more work to do. But I would say even now in 2021, I would say the problem posing research is still in the very early stage. Still a lot more work needed to be done. And today, later, I'm going to share with you some of the findings from the research project I currently engaged. Okay, so this is the little bit history about problem solving research. And the problem posing research even drew quite a bit of attention by I want to point out the 4 special issues is all on the mathematical problem posing. In 2013, ESM published a special issue on problem posing. International Journal of Education Research last year published a special issue on problem posing. And same thing in the 2020, the last issue of ESM is about the effect in mathematical problem posing. And this year, ZDM is going to publish a special issue on mathematical problem posing and problem solving. So this is just give you a little evidence that it's a pretty important topic and enjoying quite a bit of attention in the field of math education research. Even beyond, some educational researchers started to be interested in problem posing. Another evidence for the importance of this prompt posing research. Now, ICME 14, there is topic study group, which is TSG 17. It is called prompt posing and problem solving in mathematics education. Based on my knowledge, this is the first ICME conference explicitly mentioning prompt posing in a topic study group. Before that, there is no topic study group, no discussion group mentioning prompt posing. Even though some researchers did present prompt posing papers. And another evidence I want to show is that so far we have published lots of research handbooks, quite a few research handbooks in mathematics education. Now, no research handbook include a particular chapter on prompt posing, except the second edition of International Handbook of Mathematics Teacher, handbook of the PME, except for the second handbook of PME. The second research handbook related to PME has a particular chapter on mathematical prompt posing. Besides that, no other research handbooks or compendiums include prompt posing separate chapter on that. So on one hand, it's got enjoyed quite a bit of attention, but on the other hand, our handbooks haven't included that kind of a chapter yet. The point I'm trying to make is this: even though we started this research area, but still a lot more work needs to be done so that we could accumulate knowledge so that research handbook will include a separate chapter. Okay, so this is a little bit of history about the brief history about the prompt posing research. Okay, prompt posing research. Now I want to zoom into the mathematics curriculum. So what about the current math curriculum then? So the research part, it's over the years, the more and more research has involved in that kind of work. But what about the curriculum? So one thing I want to looking at is that, so I look at the curriculum, think about a curriculum from 4 levels. One is I call it planned curriculum, which is about curriculum standard. Then I will also looking at the intended curriculum, which is about the textbooks. Now, implemented curriculum, I refer to as the classroom instruction. And attended curriculum is about what students learned. Okay, the reason I use divide into these 4 levels, because I want to show you that in the planned curriculum or in the curriculum standards, there are quite a bit of emphasis on prompt posing. However, in the other three, currently got very little on prompt posing. So that's why I make this bigger and bold, shows that planned curriculum has a heavy emphasis on prompt posing, but so far not on this area. Maybe the attendees in this presentation could think about your classroom or your country's curriculum standards and textbooks, is how much prompt posing has been included. So to make my point, I will give you a little bit of empirical evidence here. So I first will look at the NCTM 1991 professional standards for teaching mathematics. So very much emphasize on non-routine problem solving. But towards to the later, it also says that students should be given opportunities to formulate the problems from given situations and create new problems by modifying the conditions of a given problem. So the problem posing is one of the highlights, in fact, in the standards movement in 1989, 1990, 1991, that time in the United States. So those curriculum standards, both curriculum standards, teaching standards, and assessment standards include the calls for problem posing, In the assessment standards published in 1995, is recommended that may use problem posing to assess students' learning and mathematical thinking. Well, even in the 1992, in the curriculum and evaluation standards, is addenda for series in the 9 to 12. It also says that needed to give students formulate and answer questions corresponding to given situations. Now, this addenda series, if those of you know the addenda series, is trying to publish a set of materials which would easier for teachers to implement the 1989 curriculum evaluation standards. So in particular, in those addenda, calls for the problem posing. Even in the because of my background, I also have background in as a Chinese American, I also have know the Chinese curriculum and the standards. So I'll give you another example. In the Chinese curriculum standards, it's very explicitly mentioned about problem posing. So it says that needed to give students experience posing problems. Needed to, from mathematical perspective, to posing problems. Should encourage and help students independently discover and pose problems. And discover, pose, analyze, and solve mathematical problems. And so the in variety of areas is talking about problem posing. And in particularly in the 2017, the newest curriculum standards in China, the problem posing even more prominent in that curriculum standards. All right. So I hope I give you, little bit of snapshot to show that the planned curriculum very much emphasized on the problem posing. But now let's take a look at it. What about the textbook? So in order to examine to what extent textbook included problem posing activities, I analyzed several elementary school textbooks in USA and several elementary math textbooks in China. So PEP is one set of textbook in China. BNU is another set of curriculum in China. Investigation is one of the textbooks in USA. And Everyday is another set of elementary school math textbooks in USA. So this table shows the total number of tasks and percentage of problem posing tasks in these 4 series of textbooks. So for example, PEP here is the total. Total means that total number of mathematical activities in each grade. So for example, let's use this one here. In 6th grade, in the PEP textbook in China, there are a total of 627 mathematical activities. But the problem posing activities is 1.75%. Of this 627 mathematical activities, 1.75% of them are problem posing. So here is the total. So what we did is that we simply do the counting. It's a very sort of a labor-intensive kind of way. We first identify each mathematical activity, then to code how many of them are mathematical problem posing activity. So if you look at the bottom, look at the total here. So it's really about little bit of 3%. And for the investigation one is 1.69% involving problem posing. And every day is 1% of the mathematical activities involve problem posing. So the proportion-wise is very small, very small. But some of you will ask me, what percentage you consider as the right amount? I do not know the answer for that. But one thing I do know, compared to the heavy emphasis in the curriculum standards, it seems to me that this percentage of problem posing activities are quite small. So certainly I don't know about the textbooks in Columbia, in the other countries. Maybe some of the audience, could look into your textbook, your country's textbook, and see what the percentage of problem posing activities involved. Okay, this is the number of the task and the percentages. Then we look into the content area. So in the content area, we divide into the 6 categories. But looking at these categories is most of the problem posing activities involved in numbers and operations. And some of the like measurement is got so few for that. And also the geometry is so few. Interestingly, for the US ones, the investigation series now got 18% of the problem posing activities involve algebra. It's because this series is embedded in early algebra learning for this textbook series. But in any case, I present this table to you. My point is that, it's in other areas like algebra, geometry, measurement, data analysis, and probability, perhaps could increase a little bit more, problem posing activities. At least it's not evenly distributed. Even though numbers and operations, that strand occupy the largest amount of time and topics in each set of textbooks. So then we also look at the kind of problem posing activity involved. The kind of problem posing activity involved. So we divided them into from the more closed to more open. So this one, it says that posing a problem that matches the given arithmetic operation. So this means that, okay, so 1 3/4 divided 1/2 equal to what? Use this fraction division to pose mathematical problems, which could use that fraction division to solve them. So very specific based on arithmetic operation to do that. And the second category is that posing variations on a question with the same mathematical relationship or structure. This type of prompt posing is that, ask students to solve a problem, then ask them, say, can you pose a similar mathematical problem, but asking a different kind of question, but still use the same information. And the third type is that posing additional questions based on the given information and the sample problem. So in this one, give a situation and give a sample problem, then says that, can you pose other problems? Can you pose other problems? But for this third category, the mathematical structure or relationships do not have to be the same. Could be different. Could be different. But the second type of problem is that the mathematical relationships or structure should be the same as the problem already given them. And the fourth one is that given them a situation and then pose problems. And this one is that, so the unconstrained prompt posing task is really means that is fairly open. For example, you walk into a room, whatever you see, pose mathematical problems, which could, based on the information you digested from this room, you could solve it. So that it's really, I don't know the reason, and I couldn't interpret why that's the case. So apparently, the larger percentage of the prompt posing tasks in the 2 US series involving the prompt posing based on arithmetic operations. But for the Chinese textbooks, is the vast majority of them involving the, given situation, given the sample problem, then ask them to pose additional problems for that. All right, so go back to this diagram. We got quite a bit of emphasis on curriculum standards, but so little emphasis on the textbooks. But textbook is very important for teachers to use so that they could have their classroom instruction, right? So if the textbook got so few prompt posing tasks, then obviously the not so many prompt posing tasks has been implemented in classroom. So then what we should do then? What we should do? So one way we could do is that, well, we wait until the textbooks including a lot more prompt posing tasks. Then teachers could implement prompt posing tasks into classroom. But personally, is that probably shouldn't wait, and perhaps teachers could learning to teach through prompt posing. They could, based on existing textbook with a few prompt posing tasks, but convert them other kind of mathematical activity into prompt posing activities. So the research project I'm going to share with you is really based on this idea. The idea is that teachers are very busy already, so we could develop a few easy to use, easy to follow strategy for teachers to convert existing problem solving activities into prompt posing activities, so that teachers could teach mathematics through prompt posing. Okay, so the theoretical framework. Here is the theoretical framework for this. So it's a teacher learning how to teach through prompt posing, and to know what is prompt posing. So hopefully through teacher learning, could increase their knowledge about problem posing and problem posing instruction, and could change their beliefs about problem posing and problem posing instruction. After that, could change their classroom instruction, and eventually could improve students' learning, student learning. So the project is designed in this way to looking at different aspects, And so the another idea is we use to design this project is that teachers as curriculum lead designers, in the sense that teachers could convert some of the problem posing, some of the mathematical activities into problem posing. So three whole strategies. First one is that empower teachers to reinterpret existing curriculum materials and reshape them in simple ways that create learning opportunities for mathematical problem posing. Second strategy is that to enhancing existing curricula with additional problem posing tasks that include support in the form of sample posed problems. For example, the existing textbook include a lot of problem posing or problem solving tasks. Teachers could use those problem solving tasks, simply ask students to say, can you pose additional problems which fit such conditions? See, that's the second strategy. Third strategy is that to encouraging students to pose problems at different levels of complexity. For example, give them a situation, says that pose an easy problem, pose a moderately difficult problem, and then pose a difficult problem. So our goal is that these three strategies would be easy for teachers to follow because they are so busy already in their daily teaching. So far, based on our about 3 years the research right now, and teachers find accessible for those ideas. So next, what I'm going to do is that I'm going to show you a little bit the initial findings from the three research sites. Then after that, I will stop and open up for the questions. Time goes very fast. Maybe I should, okay. I'm going to skip a little bit, okay? I know the time, I want to give you enough time to answer your questions. So this is about a workshop we did to the teachers, how teachers change their beliefs and their problem posing skills, as well as their design of the problem posing lessons. So I'm going to skip this. Okay. So I want to give you the little bit more information about from second site and third site. So second site, our focus is on developing teaching cases. So let me show you a little bit of information about teaching cases, okay? So first lesson, teaching case 1 is that using problem posing to teach elementary school students about equation solving. So in this lesson, has 3 tasks. Here is the first task. The first task is that there is a balance, got X as a block and other blocks there. The other block is that each one is considered as one unit. Then ask students to, based on this balance, to pose mathematical problems. In this particular lesson, the teachers ask students to pose 2 mathematical problems. So in this equation solving lesson, instead of using word problems, convert into the equation, then solve the equation. Instead, this one is almost like reversible thinking. Use balance to set of equation, then to see what kind of problem student could pose. Then based on the problem they posed, students work together to solve them. So in this lesson, students solve their own posed problems. The relationship represented by the scale is meaningful to them. Okay, second task. Second task is change the equation a little bit. So we've got 2x on the left-hand side and 1x on the right-hand side. But then the other block is already labeled as 10. Not like the first one. Is labeled as actual physical thing there. So second one is actually is numbers and x represent the block there. So a little bit more abstract now. The same thing. Ask a student to pose 2 mathematical problems. Ask each group to pose 2 mathematical problems. Then once student pose the problems, the teachers find the typical problem to solve. Then talking about the equation solving process using the balanced scale. Come back to it. So not only have a meaning to it, but also know the steps how to solve it. And this lesson has the third task. Now, third task is that given the equation x minus 25 equals 60, what real-life problems can you create so that this equation can be used to solve those real-life problems? Again, the students will divide into the different groups, and each group pose 2 problems. Then teachers select typical ones, important ones, based on the learning goals of that lesson, to solve them together. See, the process is almost reversible, because from equation to the situation, to build up meaning of the equation solving process. Let me give you one more example. Case two. This is a review lesson. Entire lesson is based on this proposing task. With the following numbers and a symbol, please pose 1 easy problem and 1 difficult problem involving percentages. Then given the 40, 50%. So each student needs to pose 2 problems. Then the teachers ask students, once they posed 2 problems already, ask students to present their problems on the board. Then, according to the percent order problems, divide them into different categories. So categorize the percent order problems. Then, from each category, choose the typical ones to solve it. That entire lesson based on that, and reviewed all kinds of problem solving, and percentage concept involving percent. I'm going to have to skip the next case. This one is using this diagram, using this problem posing task to introduce the parameter, this concept. So let me go into the side 3. Now, side 3 is the only site we use involving the student data. So I will present a little bit of data to you, but it's the first year data. By this summer 2023 or 2021, by summer 2021, we're going to collect the 3 years data, even though second year is the data is not so complete because of the COVID-19. But so far, the results is very encouraging. So we use 4 measures to look at students' outcomes, learning outcomes, using computing tasks, using open-ended problem-solving tasks, using problem-posing tasks, and using mathematical disposition to assess students' learning, assessing students' learning. So I only could give you the very sort of a belief kind of only show you 2 slides, okay? 2 slides. Hopefully, by this summer, we could have a lot more to share from this student data, from this project. So this is the doorbell problem-posing task. Doorbell problem-posing task. Okay, the results I'm going to share with you is based on this. Okay, so we use the pre-test and post-test. We have 3 schools. One is below average, one is on average, another is above average. So the results across the problem-posing tasks and problem-solving tasks, actually, the one interesting finding is that the growth from pre-test to the post-test are somewhat different from students in those different schools. The below average tend to show the more significant increase compared to the above average schools. In fact, students from above average schools, the change does not show the significant difference. And similar results has been found in the problem-solving tasks. Problem-solving tasks. And the interesting part is that for the mathematical disposition measures, all show the growth, all show the changes from pre-test to the post-test, from the pre-test to the post-test. All right, so far from these 3 sites, and the results are quite encouraging. So to quickly summarize, and then I will stop and take any question you may have, is that, well, it is very encouraging that through workshops, through an ongoing kind of a PD, teachers are willing to learn, are capable to learn, to teach through problem-posing. And teachers actually could develop very interesting problem-posing teaching cases, develop a variety of lessons using problem-posing. And the students, the teachers not only change their beliefs about problem-posing and problem-posing instruction, but also their own problem-posing abilities or problem-posing performance has been increased over the years through the variety of workshops and ongoing assistance. And students so far shows the very positive results. And I didn't show you the control group. So in each school, we have a control school, do the similar kind of measurement. And so compared to the control school, and the students in the experiment group show the positive changes from pre-test to the post-test in the first year. All right, so that's I'm going to stop here, and I'm going to stop sharing, then take any question you may have.
All right.
I see lots of things here. Some of them I'm able to read, some of them I don't. So Maria, am I supposed to read in the chat and respond to it?
We will have time for one question.
Oh, one question. Okay, go ahead. Anybody want to? Sorry, I didn't give you enough time to ask me questions. I really should have cut more.
Right. So La pregunta, the question is, how can problem posing help? Oh, it moved. Just a second. Oh dear.
Okay, Maria, there is a question which is
how
to
can
me is
problem
very
posing help students to not create a model of the situation in a superficial way and help them to arrive at a mathematical model with reasoning, with what would be true reasoning and not just a mechanical way of doing things.
well, Maria, I have been reading this. I think if you don't mind, I want to answer the other question I read because to me that question is more important.
Okay.
Okay, I'll read it. Okay.
Okay.
I think it's from the Leonardo Gessler. It's called. It says that mathematical problems are often analyzed from the perspective of students learning through this problem, not from the perspective of the quality of that this problem provides us with the teaching. Would it be possible to evaluate the quality of a problem that will be posed? There are specific aspects that we can analyze to know if a problem is really a good problem before applying it with students. This is a great question. So I don't have an answer, but I do have a few points to make. If we simply just looking at the mathematical problems, not look at the posing part, okay, so there is enough evidence that the higher cognitive demand of that mathematical problems, the more likely that problem could create a learning opportunity for students. That quite a bit of evidence. Even very interestingly, in the project I have been involved, it's with the A. Silver called Quasar Project. When I was graduate student, way back, and so even if the student couldn't solve the problems present to the student in the class, but as long for the classrooms, which they engage in the more difficult, cognitively more demanding kind of problems, students from those kind of classrooms tend to show the more growth over the years, even though in both classrooms, students could not solve those problems. That means that even though they couldn't solve the more challenging problems, but they still engaged more and so create more learning opportunities. So in that regard, I think it's possible to do that. And NCTM published a book also talking about this, which is when we present the problem to students, we could looking at how to sequence it to create more learning opportunities. So there are some research going on to show that what is the good problem to use in classroom so that create more learning opportunities. But because problem posing tasks are usually cognitive demand, because it's more open, you need to make a lot of more connections. So there is a theoretical kind of basis and some empirical evidence to show that problem posing tasks could foster students' learning for that. So if you do want to make a judgment, evaluate on that, problem posing that both theoretically and empirically shows that would create more learning opportunity for students, in particularly for the so-called low-level students, because it's very low entry for them. All right, so that's 5:57 now. I used 2 more minutes, so I better stop here. Thank you very much.
Okay.
Maria.
Thank you very much. Very, very much. Excellent.
Muchas gracias, doctor Jinfa Cai, doctora Mari, muchísimas gracias y a todos ustedes por continuar conectados en este evento. Les pedimos que nos acompañen unos minutos más para hacer el cierre formal, para tomar la foto final y para hacer el lanzamiento del MEM 2022. A continuación, invito a la doctora Mari Folk para dar unas palabras de clausura.
Sí. Muchas gracias, Ángela. Sí, yo tomaré 30 segundos. Quiero dar las gracias a todos que hicieron una contribución a lo que creo que es un éxito rotundo en el MEM 2021. A todos los que contribuyen, que compartieron sus conocimientos, sus análisis, su experiencia con generosidad, con experticia y con inspiración. Muchas gracias a todos.
Los invito a que por favor vayan encendiendo sus cámaras mientras escuchamos las palabras de lanzamiento del MEM 22. Doctor Osvaldo.
Gracias, Ángela. Bien, miren, gracias a todos. Queremos darle muy brevemente, coincidimos con la doctora Mari, las gracias a todos los conferencistas, a todos ustedes los que están acá, y los invitamos a todos para el próximo año, febrero, 18 y 19 de febrero, al MEM 2022. 12 simposio de matemática y educación matemática, 11º Congreso Internacional de Matemática asistida por computador y segundo simposio de competiciones matemáticas. Bienvenidos todos al próximo evento y desde ya a preparar los trabajos. Los conferencistas están invitados de nuevo y nos vemos el próximo año. Muchas gracias. Entonces ahora, como decía Ángela, le pedimos a todos, por favor, dejamos de compartir pantalla y le pedimos a todos, dentro de sus posibilidades, que pongan sus cámaras. Le pido a los profesores que hemos estado en el comité organizador tomar fotos por cada una de las sesiones. Tenemos 10, tomen todas las fotos necesarias para después hacer el montaje de la foto final. Muy atípica a las que ustedes vieron al inicio del evento, por supuesto, donde eran presencial. Entonces ya comenzamos a tomar fotos. Yo les aviso, por favor, cuando acabemos. Son 10 fotos y los demás también están tomando. Por favor, les pedimos que no escriban en estos momentos en el chat porque me salen acá los mensajes y tapan a los que tengo abajo. ¿De acuerdo? Vamos por la 4, vamos para la 5 en estos momentos, por favor. La 5 nuestra, le pedimos que nos conserven la imagen para tener un recuerdo de todos ustedes y del evento, para que lo puedan ver en el próximo año. Momentico. Ya voy para las 7, faltan 3 nada más, ya le aviso. Aquí tenemos a Magda Rojas y a Violeta, que no lo han puesto, por favor. Estamos en la 8. Ya vamos para la 9. Bueno, gracias a todos. Hemos concluido. Ángela.
Queremos darles las gracias a todos por su acompañamiento, a los conferencistas y a los panelistas por compartir con nosotros sus experiencias, a todos ustedes profesores, investigadores inquietos por la educación en matemáticas. Mil y mil gracias porque el éxito de este evento se debe no solo a un equipo logístico que hay detrás, sino a la excelente participación de todos ustedes. Nos vemos entonces el próximo año. Muchas gracias.